All right, we are in section 5.6, graphing linear inequalities in two variables. So here's what you're going to learn today. You're going to learn how to check solutions of inequalities, how to graph linear inequalities in two variables, and how to use them in real-life problems. Now, a linear inequality. You already know what that is. You've done linear inequalities before. You've graphed them by using an open or closed circle. You've shaded to the right or left. But now we're going to graph a linear inequality in two variables. So that can look like this. ax plus by is less than c, is less than or equal to c, is greater than c, or is greater than or equal to c. Now, a, b, and c are real numbers. A solution of a linear inequality in two variables is an ordered pair that makes it true. Now, these two problems, you can do them on your own, but we're going to start really easy. How do you check to see if an ordered pair is a solution to the inequality? You'll notice in A, we are given the inequality 2x, that does not look like a 2, let's try that again, 2x plus y is less than negative 3. If we plug in the value of x and y, that gives us 9 minus 2, which is 7 is less than negative 3. That is not true. 7 is not less than negative 3. Therefore, this is not a solution. Not a solution. Now, if you want to try the next one on your own, you can. Otherwise, you can skip ahead. 2, we plug in negative 2. That would be 2 plus 6 is greater than or equal to 8. That is true. So, negative 2 is a solution. So there's the easy part. But now we're going to graph them. So here's what we need to know. Before I even go over any of this, you are going to graph the equation or the inequality as an equation. And from there, you're going to determine, using the inequality, whether you're going to shade above or below the line. And also, if the line itself is going to be a solid or dashed line. So, the graph of a linear inequality in two variables shows all the solutions in the inequality in the coordinate plane. Your solution for an inequality will be the shaded region on a coordinate plane. So in this problem, all solutions of y less than 2x lie on one side of the boundary line. So anything, so if I wanted to graph y is less than 2x, all of your solutions are represented here in this shaded blue region. Now, what do? They graph the boundary line. Now, the boundary line is y equals 2x, which you'll learn about that in a second. A boundary line is just the inequality written as an equation. Now, the boundary line divides the coordinate plane into two half planes. One half plane, the other half plane. The shaded half plane in this region is less than 2x, so it's shaded below. Now, you can pause the video and write this down, but I'm just going to quickly go over this. Step 1, you're going to graph the boundary line for the inequality. You're going to use a dashed line for less than or greater than, a solid line for is less than or equal to, or greater than or equal to. Now, before we go on, I really don't like when they tell you this. While it's true, I want you to understand the meaning. Why do you use a dashed line? Because the points on the line are not solutions. A dashed line represents the line itself. And if it's dashed, the points on that line are not a solution. Now, step 2, you're going to test a point that is not on the boundary line to determine whether it is a solution. Step 3, when you test the point, if that test point is a solution, that side of the half plane is the solution. So that's the side you would shade. When the test point is not the solution, you're going to shade the other half plane, which is going to be the part that is the solution. So you're going to shade the part that is the solution. So in example 2, we're going to graph y is less than or equal to 2 in a coordinate plane. Step 1, graph the boundary line, y equals 2. Now, because it is less than or equal to, all the points on the line would be a solution. So I'm going to graph y equals 2 as a solid line. Now, you are going to pick a point that is not on that line. You can't pick a point not on that line. Now, here's a hint for you. The hint is that it is often convenient to use the origin as the test because it's an easy point. However, you must choose a different test point when if the boundary line goes to the origin. So if I plug in 0, 0 to my inequality, 0 is less than or equal to 2. That is true. So since 0, 0 is true, that's the part I shade. So I would shade this side. So all of your solutions would lie underneath the boundary line. So now we are going to graph example 3. Now once again, you can graph however you would like. You want to use slope y-intercept? Great. You want to use intercepts? Absolutely. You want to make a t-table? Perfect. So I'm going to do intercepts. So I'm going to graph the equation negative x plus 2y equals 2. That means my x-intercept is going to be negative 2. My y-intercept is going to be, what do you think it is? It's going to be 1. So I'm going to make a point at negative 2, a point at, that would not be right. That's on the wrong axis. So the x-intercept at negative 2, the y-intercept at 1. Because the points on the line are not a solution since they're greater than, it's going to be a dashed line. Now I'm going to pick a point, not on the line. Hey, I'm going to pick 0, 0 because that's super duper easy. So let's see, 0 plus 0. That would be 0 is greater than 2. 0 is not greater than 2. So that means that 0, 0 is on the side that's not a solution. So I need to shade above the line. So let me shade above the line. And so everything in the shaded region would represent solutions to that inequality. Example 4, our last example. Let's do one involving a fruit salad. And here we go. You can spend at most $10 on grapes and apples for a fruit salad. Grapes cost $2.50 per pound and apples cost $1 per pound. Write and graph an inequality that represents the amount of grapes and apples you can buy. Identify and interpret two solutions of the graph. So step 1 is going to be writing our inequality. So try to do that again. Try to write that on your own. All right, so if you did it, we want to spend grapes $2.50 per grapes. So X is the amount of grapes we need, plus Y, which is $1 per pound of apples. So X is the number of pounds of grapes, Y is the number of pound per apples. We want to spend at most $10. So at most 10 means less than or equal to $10. Now if you graph that, that will give you an x-intercept of 4 and a y-intercept of 10. But the most important thing is interpreting how we're going to graph it. So looking at how we graph this, y-intercept of 10, 4 is my x-intercept. I label. I put a title. Now, because it is less than or equal to, that means all points on the boundary line are a solution. It's a solid line. But you'll notice I can't have negative pounds. Therefore, I don't have arrows at either side. And if I picked 0, 0 to plug in, it would work. So I shaded everything underneath. That means everything underneath is a solution. So now it says to identify and interpret two solutions. So one solution could be 2, 5, because it's on the dotted or the solid line. And 1, 6 is the other solution. So one possible solution is 1, 6, because it's shaded in the half plane, another is 2, 5. If I interpret it, that means I can buy 1 pound of grapes and 6 pounds of apples, or 2 pounds of grapes and 5 pounds of apples.